Domain and range are by far the most important concepts in functions, and there is a very high likelihood that you would see a question based on them. What is a domain? In simple words, the domain of a function is a set of all possible input values. And what is the range of a function? The range is a set of all possible output values. The domain is the set of all values that go into the function, and the range is the values that come out. So if we have a function like y is equal to f of x, the domain will be all possible values x can take, and the range will be all possible values for y. Is there any good way to remember this? How do we remember that the domain is all possible input values and the range is all possible output values? Maybe something like d comes before r and x comes before y. Domain is x and the range is y. Okay, nice. Shall we try out a few examples now? The first function is f of x is equal to x. This function will simply give out the value it takes as the input. Instead of saying it does nothing, a better way of saying it would be the function multiplies the input by 1 and gives an output. Anyway, coming to the point, what will be the domain and the range of this function? Domain will be all the values x can take. In this function, x can take any value. Yes, just about any value. So the domain is all x. And the range, which is y or the output, can also take all values that x takes. So the range will be all y values. Here's the second function. F of x is equal to x squared. What will be the domain and the range of this function? Try it out. The input x can take any value, so the domain will be all x. The range is interesting. Will it be all y? It will be all y greater than or equal to 0. Why? Because the square of any number cannot be negative. It will always be non-negative. To give you some good news, there are two main constraints that are very common in the exams. Look at this function. F of x is 1 over x minus 2. What is the domain of this function? Domain is the set of all possible input values. Can x take any value here? Yes, all but one value. The domain will be all x except x equal to 2. That's the first constraint. The denominator has to be a non-zero, cause if it is a 0, then the function will be undefined. Easy? Here's another one. What is the domain of this function? Can we have a negative number within the square root? Well, I don't think we can. So, x minus 3 will be greater than or equal to 0. This means x has to be greater or equal to 3. X can take any value which is greater or equal to 3. That brings us to the second constraint. Even roots can have only non-negative numbers under them. Remember this well. The denominator has to be a non-zero, and even roots cannot have a negative number under them. Now for the last problem of this session, find the range of this function. By range, we mean all possible output values. Look at this term. Can it be negative? No. The square of any number will be greater than or equal to 0. So the minimum value of the function will be 0 plus 1, which equals 1. F of x will be greater than or equal to 1 as x squared will be greater than or equal to 0. So that was all about domain and range. But the most interesting concepts related to functions are to do with their graphs. We will see those in the next few sessions. In the previous session, we saw the graph of the function f of x is equal to x squared. It was a curve like this, a parabola. We just substituted different values in place of x, got respective values for y, and plotted the points to get this graph. It touches the x-axis at the origin. That's because when we substitute a 0 in place of x, we get the value of y or the function as 0. Let's try making a few changes to this function. We change the function to f of x is equal to x squared plus 1. Make an attempt to draw an approximate graph of this function. When x is 0, y will be equal to 1. 0, 1 will be one of the points on its graph. If you try out more values, you get a parabola like this. Interesting. Now try drawing the approximate graph of this function. When x is 0, y will equal 0 minus 1, which is minus 1. 0, minus 1 will be the point. The parabola will look a bit like this. What is the point of all this? All the functions you see here are quadratic. The degree is 2. The graphs are not straight lines because the equations are not linear. What is the general form of a quadratic function? F of x equal to ax squared plus bx plus c. That's the general form where a, b and c can take numerical values. Do you remember how we had calculated the roots of a quadratic equation? The roots will be the value of x for which the function will equal 0. Yes, the roots are minus b plus minus root of b squared minus 4ac over 2a. Depending on the values of a, b and c, we get the roots of the equation. To know how many roots an equation has, just this value is enough. If positive, then 2 roots. If 0, then 1 root. And if negative, then no roots. Look at these functions. They're all quadratic with b equal to 0. So let's see what b squared minus 4ac tells us in each case. In the first function, a is 1, b is 0 and c as well is 0. This will equal 0. It means we have just one root here. And guess what? The function graph also tells us that it has one root. Root is nothing but the value of x as y is 0. Here at this point, the value of the function is 0. Just one root. Let's move on to the second function. b is 0 and a and c are 1 each. This will equal minus 4. Negative value of this means no roots. Does the graph also stay the same? At what value of x is the function equal to 0? Look closely. There is no such value of x at which the function is 0. It has no roots. The third function is interesting. b is 0, a is 1 and c is minus 1. This value equals 4. This is positive and hence it should have 2 roots. Does the graph say that? Absolutely. The value of f of x is 0 at these 2 points. They are the 2 roots of the equation. Remember, to know how many roots an equation has, we just need to look at the value of b squared minus 4ac. 0, then 1 root. Positive, then 2 roots. And negative, then no roots. Quadratic functions is the favorite topic of the paper setters. You really need to understand them well. Y is equal to x squared. How does the graph look? Like this. So we know this well. What about y equal to minus x squared? How will its graph look? Simple. It will look like this. If it's the negative of a function, we just invert it. To see how we get this, just try substituting different values in place of x. Okay, good. How do we draw the graph of y equal to 10x squared? It will look something like this. You see that when we multiplied x squared by 10, the function's graph narrowed. Be patient, we're getting to the point. The next function is y is equal to minus 10x squared. The minus will just invert the function. It will look like this. Let's summarize all that we saw. If a is positive, by a I mean the coefficient of x squared. If a is positive, the graph always opens upwards as in these two cases where a is positive. And if a is negative, then the graph will open downwards, as in these two cases. There's another thing we can derive looking at these graphs. When the absolute value of a increases, the curve gets narrower. 1 became 10 and we saw that the curve got narrower. And we can say that if the absolute value of a reduces, then the curve will get wider. 10 to 1 and the curve got wider. So no matter what quadratic function you face, you should easily be able to draw or interpret its graph. Draw a graph of a function y or f of x equals to x plus 1. Y is equal to x plus 1 is the function. How do we represent this on a graph? We can easily manage to draw its graph provided we know what a coordinate plane is. It is simply a surface on which we can plot points, lines and curves. It just makes life easy as it has the x and the y axis. Now how do we plot this function is the question. To plot it, all we have to do is try substituting a few values in place of x and get different values for y. What will be the value of y if say x is 0? 0 plus 1 is 1. When x is 0, y is 1. This point will be 0, 1. What if x is 1? If x is 1, then y will be 2. So 1, 2 here. If x is 2, then y will be 3. 2, 3. Honestly, even 2 points are enough to draw the line of this equation. But let's also try out a few negative values of x. If x is minus 1, then y will be minus 1 plus 1, 0. Minus 1, 0 will be this point. And if x is minus 2, then y will be minus 1. If we join all these points, what we get is a straight line. So, this is the graph of this particular equation. It is a straight line because it is a linear equation. Its degree is 1. What if the degree isn't 1? Let's see. Plot the graph of the function y is equal to g of x is x squared. Try drawing it on the xy axis. What will be the value of y if x is 0? Square of 0 is 0 and hence y will also be 0. The point will be 0, 0. If x is 1, then y will be 1 squared, which is also 1. So 1, 1. If x is 2, then y will be 2 squared, which is 4. 2, 4. It's interesting. It's definitely not a straight line. What is it? What if x is minus 1? Y will be the square of minus 1, which is 1. This will be the point. Minus 1, 1. If x is minus 2, then y will be the square of minus 2, which is 4. Minus 2, 4 is the point. Joining all these points, we get a curve. And it's called the parabola. Plotting and understanding graphs of functions is fun. And it's also very important for your exam prep. We will look at more functions in the next few sessions. we will look at in this session is y or f of x equal to the absolute value of x. How do we plot this on the graph? When x is 0, y as well is 0. 0, 0 will be one of the points. If x is 1, then y as well will be 1. This point is 1, 1. 2, 2 will be another point. And what will y equal when x is minus 1? The absolute value of minus 1 is 1. The absolute value just ignores the sign of the number. Minus 1, 1 will be another point. And similarly, minus 2, 2 will also be another point. The graph will look a bit like this. This is the graph of the absolute value of x. This graph also tells us that no matter what the value of x is, the absolute value will always be non-negative. It lies entirely in the non-negative region of y. Let's try modifying this function a bit. What if the function is f of x is equal to absolute value of x plus 1? Will you be able to draw a graph? Try it. If x is 0, then y will be 0 plus 1, which is 1. 0, 1 will be one of the points. If x is 1, then y will be equal to 2, 1, 2. And if x is 2, then y is 3, and so on. If x is minus 1, then y will be absolute value of minus 1 plus 1, that'll be 2. Minus 1, 2 is the point we are talking about. And in the same way, minus 2, 3 will be another point. This is how the graph will look like. Notice what happened. We added a constant to the function and the graph moved up. We added 1 and the graph moved up 1 unit. Will the graph move down if we subtract a constant from the function? Look at the next function and try plotting its graph. Here, we have subtracted a 1 from the original function f of x is equal to the absolute value of x. If x is 0, y will be minus 1. We mark the point 0, minus 1. If x is 1, then y will be 0. 1, 0 is another point. 2, 1, and so on. Now if x is minus 1, then y will be 1 minus 1, which equals 0. Minus 1, 0 will be that point. And similarly, minus 2, 1 will be another. Joining the points, the graph will look like this. Compared to the original, we can see that it has moved down a bit. So what are the conclusions we can draw? If y is equal to f of x is the original function, and we add a constant to it, the graph will move or shift up. And if we subtract a constant from it, then the graph will shift down. This concept is very important. What if we add a constant to the input? Something like y is equal to f of x plus 1? What will happen to the graph? Let's see that on a new page. We know the graph of our original function f of x is equal to the absolute value of x. What if the function is something like y is equal to absolute value of x plus 1? Here, we added 1 just to the input x. If x is 0, then y will be 1. If x is 1, then y will be 2. If x is minus 1, then y will be 0. If x is minus 2, then y will be absolute value of minus 1, which is 1. So minus 2, 1 is another point. And minus 3, 2 will be another. Joining the points, the graph would look like this. Comparing it to the original graph, this one has shifted to the left by 1 unit. Adding a constant to the input shifts the graph towards the left. And what if we subtract a constant from the input? Try drawing the graph for this function. When the value of x is 0, then y will be the absolute value of minus 1, which is 1. When x is 1, y will be 0. When x is 2, then y will be 1. 3, 2 and minus 1, 2 would be a couple of more points. And drawing the graph, we can see that it has shifted towards the right. Conclusion: if we add a positive constant to the input, the graph will move towards the left. And if we subtract a positive constant from the input, the graph will move towards the right. All the 4 concepts you learned in this session are important. These 2 as well as the previous 2. If you haven't understood this video well, I suggest you watch it again.